Welcome back, B.F.D followers, and we are finally on to doing some fabrication. Today we're going to be working on our head tube, and what I've done is I've done a quick sketch of what we're going to be making, and I've laid out my materials, and I have some tools that I'll also be using. And I just want you all to know, again, I have some tools that you may not have, but I'm going to tell you how you can go about doing exactly what I'm doing with, I'm just going to say, lesser tools or more rudimentary tools. Okay, so hang tight. First thing I want to show you is a really poor sketch. We've already determined that my head tube is going to be 4 inches long, and I'm going to be using a headset that is for like a 44 millimeter insert. And so what we're going to look at is the requirements and the material. All right, so here we go. What I have here is just a really rudimentary sketch. And up here, I'm just pointing to the actual head tube right there. And then down here is the material that I'm going to be using, let's say, and it's going to be a 4-inch tube. And I put some millimeters in there if you like to use millimeters. And as you can see, it's also 1.85 inches in diameter. Well, maybe more like which gives me about a 44 millimeter diameter tube. Okay, now that's going to be critical because you need to buy a headset that has the right dimensions for the insertion. So this tube has 53 thousandths wall thickness. So I will chamfer and mill out some of that material for the headset to press in correctly. Okay, so you always want to make sure that your head tube has enough material to account for whatever the inside diameter or outside diameter of your headset insertions. Okay, so there you go. Quick and dirty, no thrills, geometry, sketch. And I recommend that you always sketch out your project that you're going to do. At least put the numbers down that you're looking for and verify. So when I say verify, you're going to want to take the actual material and check it to make sure that you got the right stuff. All right, because the last thing you want to do is have your head tube wall thickness to be too thin and you blow it out. You might be able to actually get the headset to insert, but then there's not enough material for safety margins, and the loads that you put on that as you're riding, especially if you're doing mountain bikes and if you're doing any type of jumping or enduro riding, you're going to want a more robust head tube. And so you want to make sure you have enough material thickness to support the use. Okay, so in my case here, I have my raw stock here, and believe it or not, this used to be 5 feet long, and I've just been slowly whittling away at it, making bikes. And I actually like this size head tube for mountain biking. I've used tapered head tubes, and I like those, but the reason why I'm not going to show a taper head tube is because they add a level of difficulty again when you have to mate your top tube and your down tube to it. Because of the taper of the headset, you have 2 different cuts within each tube, and it just adds a lot of complexity to it. So I recommend straight gauge, straight tubes. Okay. So here you can see my tube, and what I'm going to do is just mark out the length that I want, which is a 4-inch head tube, right? 4 inches. Now, I'm going to use a term here, scarf material. So when you cut your material, let's say I do a 4-inch cut, right? It's going to be that long. And if I measure 4 inches on that edge right there and go and cut on that, I don't have a 4-inch tube anymore. So if your dimensions are critical and you really want to be accurate, you have to account for the scarfing of the saw blade and or your angle grinder, whatever cutting tool that you're going to be using. Okay, so be sure to account for that. And one other thing to account for is when you face these, you're going to take more material off of this. And when I say facing, before your headset can go on there, you want to make sure that the ends of the tubes are parallel to each other and level. No flaws in them, okay? So that's going to be more material. So it's always best to add maybe, I don't know, 1/8 of an inch to even maybe up to 1/4 inch that allows you to cut and then face. And then you can always slowly bring the material length down to meet your requirements. But you can't add material, right? So be careful. So here we go. I want mine to be 4 inches long. So I'm actually going to measure out 4 inches plus 10 thousandths. And so that's 5, 4, and 10 thousandths. Ish. Close enough, right? And then I've already done it, so laid it out. And I marked it. Okay. So seeing that, now I'm going to take it over to my saw now and cut it. And what I want you to notice is where that mark is, I'll then measure it again and show you how much material was removed. If you're using an angle grinder, which if you don't have dedicated tools for cutting, you can use your angle grinder. You can even use a hacksaw, just that your angles are not going to be as precise to start with, and so you'll end up having to grind it, sand it with it by hand in order to get it to a perpendicularity between, or a parallel between each end. That's key, okay? So I'm going to take it over to the saw now and we'll cut it there. Just lining her up, making sure everything is tight. Okay, there we go. I've done this before and the table vibrated so badly that the picture gets pretty messy, so I'm going to pick it up here once I start. But I'm going to put my ear protection on and safety glasses. So here we go. You ready? Bob's your uncle. All done, all cut. This was my cut end. That was my cut end. So can tell that the prior cut maybe wasn't as clean because it rocks a little bit. And then flip her over and it rocks a little bit. So there's going to be a little bit of cleanup that's going to be needed in order to make sure that these two faces are parallel. That face and that face need to be parallel. So here you go. I just wanted to show you the product that I got here. And here's my 4-inch. As you remember, it was 4 inches plus 10 thousandths. And so what I'm going to do is just measure this from end to end. And so I lost about 2 thousandths, 20 thousandths. From starting. So that's why I said you have to take into account your blade scarf, and then also because the tube is not, these sides are not parallel right now, I'm going to have to put it on a grinder or something like that and slowly work these ends so that they're parallel. Okay, so let me go do that. When you weld, you need a path for the gases to escape and migrate. Otherwise, the pressure will build up and blow out holes. So in this head tube, we're going to call them drain holes, but you need to supply holes common to the interface area of the down tube and the top tube. So the way I like to do it is I like to place the head tube actually into the jig and then just mock it up with the top tube and down tube and mark where the center of that hole would be. So let's go do that. Can you see my jig? So here's the head tube assembly. And so what I'm going to do is I'm just going to release the dropper in there. Okay, so now my head tube is mounted, and all I'm going to do is take a pen and locate the tube that I have. And you may already have notched this. I did an earlier video where I talked about how to go about notching your tubes and measurements. I'll do that again because I didn't really like that video that much. I'm going to do this process for every tube. Alright, so now we're on the head tube. But if you didn't have it notched, you just want to position it about where you want it. And that's after you set your head tube angle on your jig. The distance from the 0 bottom bracket location out. So you have to know your jig set up. And even though we haven't covered that just yet, this is just to get an idea of where the hole will be. The hole doesn't have to be exact. It could be a little low, a little high, a little low, a little high, as long as the tube diameter will cover it. Okay, so this tube is going to be about right here, and I'm leaving about 1/8 of an inch from the bottom, maybe a little more, because that's where your bottom the bottom of your headset will sit, and it will, if it's external, it's going to come out a little bit, and you just want a little clearance. Plus you want welding room in here, material, so that you don't melt away the edge. All right, so 1/8 of an inch or so, and then I just mark the top of where the top of the hole or the tube is, right there. that corresponds to the top of the tube. And I'm just going to say, halfway down, the tube, I didn't measure this tube, but it's probably 1.5 inch tube. So, come down 0.75, and I drilled my hole somewhere right there. Okay. Now, you might want to also then, well, you do, take your top tube, and you notice I have a seat tube already installed here too. This one's going to be a bent tube, but you just want to have something that represents that in the angle. And so what you'll do is you'll take your top tube now, position it where you want it on the seat tube, all using your dimensions from your drawing. Don't eyeball it. I'm just showing you what you do to locate the hole. So I would then position this tube here and do the same thing. This time I'm going to come in from the bottom and just mark where the bottom of that tube is. Now, the reason why I did that way is because if you're being really tight with your tubes, you might have an overlap of your top tube and down tube. And so by marking the lower part of the top tube and the upper part of the down tube, I can see what that gap is, all right? And even though your drawings show it, if you're a little imprecise or eyeballing it, that's a good way to make sure that your tubes aren't overlapping. And if they are overlapping, that's just going to cause you to weld a different way. But as you can see, I don't have any overlaps. I'm good. And because I'm going to drill these on my mill, I'm not even too concerned about that these are in a line. All I want to do is mark approximately where I want. And what I'm going to do is when it's in the mill, I'll drill one hole and then just traverse across, and if it lines up here, that's where it lines up, but I'm just using the hole as a distance indicator. Okay, so you've all cut your head tube stock to length, and I hope you went and measured it and just checked and verified what you ended up getting. And what you'll find out, of course, is that it's shorter than what you started with, right? And you might not have met your drawing requirements. So now you need to make a decision: is it close enough? And I accept, plus or minus about maybe 5 thousandths. That's acceptable for me in my head tubes. Head tubes are one of those things where it's one of the tubes that doesn't have a profound effect upon your geometry when you're talking about thousandths. So don't worry too much about that. Now, when you put your tube down, did you notice that it wasn't straight up and down? Maybe it was cocked to a side, forward or backwards, depending on how you're looking at it. That happens when the blade cuts down and you don't have it totally normal to the tube. So normal, perpendicular, okay? So if the tube is cocked and you come down, raised up or down, forward or back, your blade's gonna start one location and then it's gonna migrate out or in depending on how it's positioned, and that's going to cause your tube to have an uneven surface on the top, right, or the bottom, depending on what. They're equal right now, so it doesn't matter. Either end. Okay, so what you can do is have a sanding machine that has an end on it. You can place it with the 90 degrees and then force it up into the sandpaper and slowly grind it down to a flat surface. Flip it over, do it again for the other side. If you don't have that, what you can do is just look at it, right? And you can see waves in the material. And you can highlight those by putting taking your marking pen. Black works best because it shows up really well, right? So you can come in here and blacken out an area that is high, right? And then you can take a grinder or sandpaper and just slowly whittle that down, then go back and check and look to see if you can see it. If you can see it, you know you got a problem. If you can't see it, now you need to go and check in a different way. Okay, and so the way I do it, and it's pretty, these are pretty cool blocks. They're called 1, 2, 3 blocks. And they're precision ground, and you should maintain these because they are the surfaces that you're going to be referencing things off of. This one seems got a little dirty, but anyway, some flat surface. Make sure that your surface is flat too, and then you can take your tube and you can put your 1, 2, 3 block next to it. And position it. Now, as you see, you can't see any daylight between those two parts. So that surface is flat. Now I'm going to flip it over and do the same thing for the other side. And God, that's good. So this surface here is parallel to this surface, and I don't have to do any more grinding. All right. If you don't have a 1, 2, 3 block, I recommend getting one. They're not that expensive, but you can also use a good old carpenter's angle, speed angle, and you can see that's pretty good. And matter of fact, the speed angle seems to show everything pretty cleanly too. So if you get a high-end speed angle, all the better. This is a cheap one I just picked up at Home Depot when I was building my deck. But as you can see, it worked just fine. It shows the same results basically as the 1, 2, 3 block. Cool. The other thing that I did is I went ahead and cut a couple additional rings. And what I'm going to do is I'm going to split this, each one of these, and I'm going to pull that over this and slide it down and make my own reinforcement rings. And that's just going to add additional thickness to areas where you see load on your bike. And they look cool too. And I actually cut these with a slight taper in them because I'm thinking that I want where the tubes come in, I'm going to want a little bit more clearance because I'm going to be using most of the tube. So the reinforcement ring is going to be thinner where the top tube and down tube come in and interface with it, and thicker on the front side. It's just a aesthetics thing for me, but it also gives you a little bit more surface area right here at the top where your headset is going to be pressed down in and have a surface to sit on. Okay. You don't have to do that if you have enough material on your tube. And you might be asking yourself, well, how much material do I need? Well, it depends on what type of frame you're doing. If it's a road bike, you can get away with a pretty thin tube, unless you're a big person. If it's a mountain bike, I would have at least a wall thickness of 53 thousandths, 60 thousandths, and then because you're going to have an inside diameter of 44 millimeters for your insert for your headset, you're going to be taking some of that material away in order to get it to press in. So I'm adding an additional wall thickness. So it's going to be 100 thousandths basically. I recommend anywhere from 80 to 100 thousandths for a mountain bike. Just margin of safety. All right, good luck, and I'm going to prep some stuff and I'll show you the next step. Now I was getting ready to drill the holes in here, but what I wanted to do before I did that was show you what it looks like with the reinforcing rings on there. They're not brazed on yet or welded. You can do either or, but I just thought I'd show you what it looks like. So here's what it looks like on the one end that I put the ring on, and as you can see, there's the gap. Because I used the same size material just off of the tube, when I stretch it out, it has a gap, right, as you can see. I'm not worried about that, and the reason why is because this is where the down tube is going to come into, like this, and it's going to come down. Here, I'll just grab another tube real quick just to show you. So it will come down and it will be over that. And so what I'll end up doing is I will just manually weld across there and make a little bridge. And since it's underneath the down tube and the top tube, you won't see it. So nothing to worry about, and you still get all the strength that you need. Now here you can see the surface area increases substantially, and so that gives you a really good area for your cup to sit upon. Now here's how I do it. Here's the ring, the other ring that's been cut. I haven't cleaned it up since it has burrs on it. You want to do that for sure. And all I would do is line it up with the other one like this and pull it over there, push down on it, pull up, whatever it takes to get it close. And actually, yeah, it's pretty close. I'd line them up so that they're in line with each other. They're a little off, but I'll just rotate it. All right. And the other thing I did is where I marked where the holes are, right, will be, I went ahead and just punched them. And you can do that with hole start, hole punch. All right, this is an old one. It's dulled, but hit it with a hammer, it leaves a pretty good dent. Now if you don't have one of these, you can go real barbaric, basic. Just get a nail, just a regular wood nail, carpenter's nail, and position it and give it a whack, and you'll get an indentation like that. Just enough for your drill bit to center off of and guide your hole. So that's what I'm going to go do next. I'm just going to go load it up onto the mill and drill those holes. Here we go. Just going to open up jaws here. Just drop her in there. Again, I don't really care. I mean, since I did a start, the beauty of a mill is I really didn't need to put a hole punch in there to get it started. But so I'm just going to tram it over to where I think approximately center is, just because I'm going to be drilling straight down. I don't want it to wander, but I'm just going to, in this case, I'm just going to use those holes as guides, or those punch holes as guides. Because I'm on a mill, that bit will pretty much disregard that hole, or the start. But I'm going to try to line it up anyway. You know what? That is almost dead nuts on. So here we go. I'm going to go grab some lubricant real quick. It's pretty mild and thin-walled in general, so I probably didn't have to do that, but you know, let's just save. Okay, let's see how this goes. So, oh, I don't need to take that out. What am I doing? I wanted to show you the hole size and all, but I don't really need to. What I'll tell you is that the material that you remove, as long as you're not close to the edge where the weld is and you have sufficient material, you can make these holes pretty large. Now I'm just going to move on over to the next hole, and see, this is why I was saying, you know, when you mark it, you don't have to be 100% on as long as, you know, they're in line. So I'm just spitballing it here and saying, okay, right there. Start her up. And there we go. Start cutting chips. Now you could do that with this hand drill, put it in a vise or something, and drill her up, or you can do it on a standing drill, or if you have a mill. You can even, if you want to get creative, you can mount this into a lathe and do this too. You can do a lot of milling work on a lathe. All right, there we go. Just wanted to show you what I did. I went back and drilled and verified which hole I was going to use as my down tube, and I went ahead and drilled it a little larger. And now I can actually, let me pull this out and show you. I can now go ahead and place this anywhere, forget about it, come back to it, and because the lower hole is larger, I know what side is up and what side is down now. Just a good way of idiot proofing it in a way. So now when I go and put this into the jig and or do my welding / brazing first to put these rings on, I won't forget when I come back which direction it should be in. Just a tip. So what I'm going to do here is just clean her up, get her ready for welding. And I've decided to actually TIG weld these on and give it a try and see how that looks. I've never done that. I've always brazed them on, and so I'd also like to try silicone brass sometime, but I need to practice with that, so I'm going to weld these on. Okay, but first I scrubbed them down with some sandpaper, and now I'm just going to wipe them off with some acetone. And I'm using gloves because, one, you don't want the oil from your hands to be reapplied to your clean surface, because oil is not something that TIG welding likes. So just clean the whole thing off. and then the rings themselves. So I'm not going to show you how to weld. I'm just going to show you the results pre-welding, halfway through, and then post-welding. At this point, have to assume you already know how to do some welding. You have to be careful when you do this because you're talking about the edges, and you can melt away these edges that you've got nice and parallel when you were doing all your sanding and grinding. So you don't want to overheat this. You want to be, if you have pulse settings on your welder, I would recommend using those. But I'm going to weld really light across the top, and then on the edges I'm going to fuse those down onto the tube itself. So here I got the rings installed on the head tube, and this is the surface that I'm going to lightly weld. Try to keep it nice and even so that when I face it, it'll be easy. And then I'm going to weld down on the edges here and fuse that to this tube and I'm going to try to get a kind of artistic look maybe, but we'll see how good my welding goes. And then I'll do the same thing on the lower ring. Alrighty, let's see what that looks like. Well, B.F.D. guys and gals, here's what I got. I'm not really happy with it. As you can see, when I welded it, ate away at the edges, and I thought I might like it. Get that kind of chiseled look in there. But after I cleaned it up with some sandpaper and all stuff, it was just too uneven in areas, and when I did clean it up, I kind of took some of the welds away. So if you're listening to me, like you can see right there, if it had all been like this right here, yeah, or even like this in some ways, I probably would have kept it, but because there are some really big gouges, I'm going to probably go ahead and work it out with a grinder and try to smooth it out. And I'm sure I'll have to maybe even do a whole new head tube. But, trial and error. I thought I'd try it. Normally I braze these on, and I would strongly recommend that you braze them instead. Braze them or solder. Not solder, I guess that's still brazing. Silver solder, silver brazing. But anyway, I may keep it. It makes it unique. I wonder what it would look like painted. So we'll see. All right, and that's how you do a head tube, and that is the finished up head tube. So I'll let you guys make your own decisions on how you want to do it. I'm not sure I like it at all, but again, trial and error, we'll see. All right, good luck, and if you make one, send me a post. All right, you guys, take care.